So, hello, hi everyone. My name is Francisco Barranco. I work with the University of Granada and with Eduardo Ross. But here I'm presenting a different work I did during my postdoc at University of Maryland with Yanis Alimonos, Cornelia Vermeuler, and Chin-Lik Teo. So I think Alois was talking in the morning about this. The DVS is that dynamic vision sensor. So it is a special sensor that tries to mimic the way the transient pathway of the vision sensor of the vision system works, right? So instead of seeing images like what you see in a conventional camera, right, it sees only the changes that happens in the scene. So the kind of output that you get from this sensor is a huge one-dimensional vector with elements that have, as you see here, right, x, y, and t. So x, y, the position where the change happens in the scene, and t, the time at which this change happens. And one last information that is not there in the slide, which is the polarity. So if the change was positive, so if the luminance is increasing, or negative, decreasing. So the second thing which is important for this sensor is the this one here, right? Low latency. So it works at about, that's theoretical, right? So 15 microseconds. If we try to translate these into frames, it could be something like 600,000, right? Frames per second. And that's one of the main advantages of it. And then the third one is the high dynamic range. It means that it works in the log of the intensity, not in the intensity. So if I point my camera sensor, right, to the window, I could see things that happens outside and inside at the same time, right? Well, and now what we did, we've been working on motion estimation, we've been working on depth estimation, ego motion estimation, and a lot of more things. But one of the problems that we had is that if we want to work with robots, we need segmentation first, right? So we need to know where objects are. One of the main problems that we have is, these are two examples of the current state of the art with, let's say, computer vision for these sensors. I don't know if you can see it from there, but there's this example. It's a static scene, right? And we're pointing the camera to the scene and moving it. As I said, it only sees changes. So if the scene is static, you don't see anything. So you need some dynamical motion, right? So there's a mug here, there's some box, something in the background, and then you see something like that, which is nothing, right? Because there's a lot of information that comes from the texture. You don't see where, or you don't know where the contours of the objects are, so you don't, sorry, you're not able to do anything with that. And then the second thing is you have here a car, so the car is moving, the camera is static, right? Since the car is moving, you can see it, right? But you can see something. I don't know if you see these, I don't know if you could be able to say that's a car. So that's the state of the art right now. What we did was we tried to learn how to connect all these pieces of information that we have here, right? And try to extract long contours, as you see here, that are creating a closed contour, so we can diffuse inside that closed contour and outside and say, here's the object, here's the background, right? And those are the colors I'm showing there, and that's the legend, right? So with these, I can say, well, I don't know if you're able to say what it is, but it's easier, right? You see some contour here, and something red is telling you where the object is, the foreground, something yellow, which is where the background is. That's what we did. And then once you have that, you can grow, diffuse, whatever, that information and say, that's my segmented object. So I just wanted to show this. I think it's better if you come to the poster and just ask, because the whole system is a little bit more complicated. I have the sensor, and I have the, and I have some videos, so I guess you can come and ask me. Okay, thank you.